Alright, in this problem we are doing number 6 from the classwork review problems. It says Nolan Ryan reportedly had the fastest pitch in baseball, clocked at 100.9 miles per hour, or in physics terms, 45 meters per second. If such a pitch had been directed vertically upwards at the same speed, then to what height would it have traveled? So in this problem, we are pretty much taking this maximum speed or this maximum velocity type question and figuring out, or turning it into a projectile motion problem. Nolan Ryan here has a baseball. He throws it up. It reaches a maximum speed of 45.0 meters per second. But what happens if we instead threw the baseball up at the same speed of 45 meters per second? What is the max height if we're given this max velocity? And what we have to realize is if we're comparing maximum heights and maximum velocities, velocity is essentially a code word for kinetic energy, and height is kind of a code word for potential energy. So we have to see, in this case, we have to use the conservation of energy, or the total energy initially is equal to the total energy final. And to break that down, we have potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. But we already know initially we have a, or we're comparing maximum situation. So if we're trying to do that, we know that at the maximum velocity, there should be no potential energy, and it should be all kinetic energy. And in the final potential energy situation, everything should be transformed to potential energy. So we end up getting or comparing maximum kinetic energies and potential energies. And in this case, we'll just plug in what we have, 1/2 mv max squared is equal to mgh max. As you can see, on both sides of the equation we have masses, so they actually can cancel out. And what we can use is g of 9.81 meters per second squared. 1/2 45 squared is equal to 10 times h max. Isolate h max, you divide by 10 on both sides, divide by 10 on both sides. You got a maximum height of about, oh, and I use 9.81 here, but I rounded it to 10 here. If you use 10, you'll get 101.25 meters, and if you use 9.81, you'll get 103.2 meters. So I'll make that clear. Using 10 meters per second squared and using 9.81 meters per second squared.